Hello everyone, I am Esin Ece.
And I am Sultan.
Today we will be talking about feature extraction and selection methods. The selection and extraction of features are critical steps in pattern classification and have attracted a lot of attention lately. The original data are typically extremely big in dimension and contain significant amounts of redundant features or noise, particularly for image analysis. How to select and extract the most discriminative features for various classification tasks is a popular research question. Discriminant embedding is a technique for dimensionality reduction that is used to find a low-dimensional representation of the data that maximally separates different classes in the data. It is often used as a pre-processing step for classification tasks because it can identify the most discriminative features, which can be useful for making accurate predictions. There are several methods for finding discriminant embeddings, including kernel discriminant embedding, linear discriminant embedding, and linear discriminant analysis, and so on. These methods work by finding a low-dimensional representation of the data that maximally preserves the between-class variance and minimizes the within-class variance. In the first study, authors suggest a robust sparse discriminative feature extraction method, which encourages linear discriminant analysis with implicit feature selection. To ensure that the method performs feature ranking and weighting, the regularization term is inserted into the global criterion. Next study facilitates interclass sparsity, learning a compact and discriminative transformation matrix by utilizing correlations between samples is a foundation for the proposed method. Then in the last study, proposed method is a hybrid approach that combines the strength of the first two discriminant methods to create a more powerful model. There are several reasons in proposing hybrid approaches in machine learning. This could be because of improving performance, increasing robustness, or flexibility. To mention the main contributions of the last paper, they are trying to provide a novel objective function that allows the estimation of the linear transformation and propose two initialization procedure for the linear transformation and providing an optimization algorithm in which the linear transformation matrix is estimated by a gradient descent method. As the main goal of the previous work was to improve discrimination by computing the discriminant linear transformation, which combines interclass sparsity with robust LDA discrimination. We want to improve the accuracy values here by proposing a post-processed procedure to achieve higher classification performance. In our study, we utilized two datasets and their general properties are given in Table 1.
So I will continue with the method section. So basically in the previous work, authors performed PCA. However, they didn't mention about the reasons for it. We can say that performing PCA before LDA depends on the specific characteristic of the dataset and the goals of the analysis, as the datasets are highly correlated and the goal is to reduce the complexity of the data. Using PCA can further improve the performance of the LDA. Provided objective function allows the estimation of the linear transformation, and the aim is to minimize the objective function. There are several ways to combine two transformation matrices in order to improve discrimination. Previous work take concatenation operation to it, such that a part of QRLSDA is taken and append to QICS DLSR as shown in the left bottom figure. Dimensionality of these matrices are given in the C value is the number of class labels. We utilize the proposed optimization algorithm in which the linear transformation is estimated by a gradient descent method. where Qt plus 1 and Qt denotes a projection matrix Q in iteration t plus 1 and iteration t respectively, and alpha is the step length and the learning rate. We already mentioned about use datasets and mathematical formulation step by step. We implement proposed method in Kaggle for collaboration and easy access to public dataset. In local, we run a project in Jupyter Lab. In implementation, we use NumPy, Pandas, OS, and scikit-learn libraries to process the data and implement proposed methods and show results. We again utilize these following libraries. So we implement several methods to compare the proposed methods to ensure a fair comparison in identical circumstances were employed in all test and compared methodologies. The entire dataset is randomly divided into a training part and a test part for each comparison. Embedding method, we used mean classification accuracy to show number result, and you can see the result given below. Thank you for your attention and thank you for listening.